For the spring 2021 semester IMSC capstone project, we worked with Danfoss on their medium-duty motor test cell. The ISU team consisted of me, Jenna Teberg, Quinn Meyer, and Isabella Smith.
Danfoss is a global manufacturing company that makes many different products for many different markets. So 3 of the main markets include drivers, heating and cooling, and power solutions. They were founded in 1933 in Nordberg, Denmark, and have 28,000 employees worldwide. This semester, the ISU team worked with Danfoss on their medium-duty motor line. So these medium-duty motors go into off-highway vehicles like you can see on the right. Danfoss tasked us with redesigning the test cell for the medium-duty motor assembly line and replacing the old test stand. They also tasked us with addressing and fixing the 3 main ergonomic concerns, giving us a budget of $2 million. So from this, the ISU team created 4 main objectives.
The first objective was to implement a new test stand and operator interface with a positive return on investment in 4 years. The second objective is to reduce operator travel to less than 5,500 feet per shift per operator. The third objective is to reduce test stand idle time by a minimum of 50%, therefore increasing throughput by at least 4 units per shift. And the last project objective is to reduce safety and ergonomic concerns by reducing the Rula score from 7 to 5. Once we identified the objectives of this project, we started our current state analysis. We began by doing a process analysis of the last 3 stations. We utilized 3 engineering methods: time studies, flow diagrams, and Yamazumi charts. These revealed that the south test stand had 21% idle time. This is time where the test is done being run on the motor and it's just sitting there and not being worked on. This correlates to about 927 hours each year, and reducing this time will allow us to achieve our second objective of this project. Below is a table of the cycle times that we observed through the time studies. As you can see, there's about a 4.5-minute variance in cycle times between the last 3 stations, which is something that we're looking to reduce with this project as well, to also help increase the throughput. And as well, we calculated an operator on average is traveling 1.71 miles per shift between the last 3 stations, which is a lot of wasted movements in a distance we are looking to reduce in our third objective.
The ergonomic portion, we did multiple different assessments of the current state. And so 2 of those assessments included the Rula Assessment and the NIOSH lifting equation. So the team found that from the Rula Assessment, most of the tasks performed in the test cell were scored at a 7, which indicates immediate change needs to occur. Then from the NIOSH lifting equation, the team found that the recommended weight limit for some of the lifts was 0 pounds, indicating that it was an unsafe lift. We also found that the lifting index was above a 1, which is problematic.
Every year that the outdated test stand was not replaced, it is predicted that a catastrophic failure would happen within the year. A catastrophic failure would result in 6 weeks of half production because that test stand would be down and need replaced. This came to a total of about $414,000.
Once we identified all the areas for improvement on the current state analysis, we began with our future state. The first part to the future state was a new layout with the new test stand, satisfying our first project objective. Pictured up top, the white looking box with all the panels is the new test stand we put in there. And then also it's connected to an automatic feed conveyor. That's one of the main parts of this design, to where an operator is just setting it down and picking it up at the beginning of the conveyor and at the end, pretty much automating the testing part of this process.
We worked to create a work content design that would be equal to the machine's automated loading, testing, and unloading of the unit, so that either 1 or 2 operators could successfully complete other tasks during that time without any idle time for the machine. As you can see, this is balanced and below takt time.
And then for the ergonomic and safety aspects of the future state design, the team made some changes, including making the horizontal distance on the test stand less than 25 inches, using the hoist more, and adding some safety training. So some of the outcomes of this would be the need for manual lifting is basically eliminated, the transportation distances are decreased, and overall the lift frequency and weight is decreased.
Once everything is implemented, they can expect to have an average yearly return on investment of $1.17 million from all of the improvements presented. All of our objectives were addressed and satisfied, and the net present value of the investment comes to $300,000 after their 4-year payback period. Thank you.